Well, that one doesn't want to stay. So I'm going to try pulling it back down the hole one more time. Sometimes the slip fit tapered hole won't work to hold the lock nut. You'll have to use some glue on it. Okay, let's try this again. I've got it seated down there pretty far. I'm going to try to take this out without... Oh, see, now it already slipped. Yep. Alright, this one is going to be a little stubborn. So, my next trick, pull that part way out. Take a little bit of CA glue and just put it on one side of the lock nut, just like that. See that little dab of glue there? And I'm going to push this back into the hole. Give it a little squirt of accelerator. And then tighten up the screw again. That's going to pull it down into the hole a little bit further. While that glue is setting up, I'll just leave that there. Okay, so now I should be able to knock that lock nut out if I need it back. And hopefully this time it'll stay put. Accelerator works pretty fast. I'm going to put my finger on top. Got to watch out doing finger contact on the end of screws. I keep taking my finger off to keep any bit of that screw tip from cutting into my finger. All right, this time the lock nut stayed in place. Okay. So now, very quickly here, I'm going to put these two pieces together. I'm going to put 20 millimeter M3 socket head screw in place here, and then I'm just going to twist this as far down as it threads before the thread lock starts up. I'm not going to tighten this down all the way just yet because, as you can see, there's a bit of a gap that's opened up. There we go. Let me find that other... here we go. Second socket head M3 screw. I did not clear out these holes. This one needs a little help. So I'll get my round needle file, just lightly go through that hole there. Better. All right. So I'm going to cheat here. One way to open up a hole, use the needle file a little bit, and then the threads on the screw itself, once you screw this all the way down, can be used to strip the hole out to the correct size. There we go. The head is bottomed out, so we're turning freely now. Let's take this piece, thread it on, and tighten it down. Watch out your fingers don't get gripped by that closing gap right there. Okay, now the neat thing about these mounts, on my Hellcat, the tabs are standing straight out like this, but on my utility plane, since I wanted it to attach to the battery hatch, I turned them like this in order to screw them into the wood I'd attached to the hatch, because it was shorter. So you can position these any way that you need to. If you have the room for an online positioning, it's slightly better from a drag point of view. But right there, except for mounting the servo, that completes the assembly of the actual pylon itself. So when you put these on, these are 20 millimeter tall. They're 16 millimeter, but I find that not quite enough of the 16 millimeter will go through the lock nut threads. So I'm willing to have that wee bit of screws sticking up, and I will grind away a little trough of that wherever I fit it onto the airplane. It'll be hidden by the attachment. And if you take this off, and this is just me, if I really need to cover the hole, I'll use a piece of Scotch tape. All right, so next we're going to do the servo fitting. All right, I said next we would do the servo fitting, but then upon looking at this, I realized I've forgotten a crucial step. So let's disassemble here. That crucial step is I haven't removed the obstructive material on the linear gear. And just look at that linear gear. It's all dirty. And what I mean is there's plastic sticking out. It needs to be cleaned up. So disassembly is easy. There's linear gear. And look at all that plastic, that tooth, this tooth, this tooth, this tooth. That all needs to be cleaned up. They need to be that triangular shape, so that needs to be very carefully cut out. And for that, I will use a wedge-shaped straight edge. In other words, this edge is straight. And this cutting edge on the end is fairly straight. But what I need to do is go in and file these teeth. Help if I have the narrow end in the slot there. That's what I get for looking at the video screen instead of the part. I want to make sure this part is in focus. I'm using my cell phone, and it seems that the autofocus is kind of picky about hand positioning and part positioning, etc. Okay. It's a little bit rough, but the teeth are a lot cleaner. So I'm going to go over this until I'm satisfied that the teeth are going to mesh smoothly with the servo gear teeth. And speaking of, the servo gear teeth also need cleaning up. I'll use the same tool for that. Careful not to overdo it. You don't want to cut the tooth down. You just want to clean up whatever artifacts your printer may have left behind. Now, in the case of this, since it was printed on this flat surface, there is material all around the edge here that's kind of an overhang. Now, it's not really necessary to go around this circle like this, but I'm cleaning up the rest of it, so I may as well clean up that. Alright, I'm going to get my larger flat file, clean up the top of the teeth, and go back over it with the wedge again. You want to make sure that we're going to get an unobstructed roll here. And it looks like on this last tooth here, it's still a little thick. Now, when I was working as a machinist, we called this overhang flash. Something similar in plastic models, removing flash. In machining, it happens from a grinding process. If you're grinding the tooth, let's say from this direction to this direction, there'll be a small curl of metal where the cutting tooth exits the piece, and that flash will need to be ground off. Now I'm flattening out the bottom spaces also. All right, now let's see what we've got. Seems to roll pretty good there. I'm detecting a little bit of extra material in this last tooth. So it's inside between the teeth that it's most important to get the material to a nice smooth shape. If you accidentally take too much off of a tooth, don't worry too much about it. One of the great things about working with plastic is if you really mess it up, you can often restore the shape with a carefully applied drop of CA glue, let it harden, then reshape the piece. Okay, I'm not sensing any obstruction there. Now I'm paying attention not only to what this looks like, but also what it feels like when I run the teeth through. Is there anything scraping? Is there anything that feels off? Like right here. Maybe there's a little extra material right there. Maybe it's on this side. All right, that feels pretty good. Okay, now it's time to move on to the next spot, or the next step. Now that the pylon is assembled, we need to prepare the servo and the gear. All right, so what I've done is I've taken a single arm servo arm here and inserted it into the short servo gear and then cut it off so that the end of the arm was flush here. Now I can pull this out. All right, so there's the 3D printed gear, and the servo arm has been cut down. I've cleaned out the hole so it fits, and then this gear is going to be installed with the rod in the closed position. So the linear gear is all the way forward. All right, so the servo goes in this direction. And I want the final tooth right there to be resting in the gap between the first and second teeth on the linear gear. Just like that. Okay, now it's really of no great consequence. That opening is opened up a little bit. You can probably, if you have a digital travel adjustment on your radio, as I do, just adjust the travel until that disappears. Okay, so now I need a screw for the servo gear. Well, see, I don't have to hold everything together there. Let me get that started. Unfortunately, my fingers are obscuring the hole from the sight. There we go. Okay. Now, I'm going to need to clean out these holes just a little bit here. I don't want my servo mounting screws to accidentally split the plastic. Okay, let me see if I can find some more appropriate screws. Okay, got some more appropriate screws here. I cleaned out the holes. This is the first time I've threaded this screw through the hole. It's fitting pretty good. And unless I over tighten them and strip out the plastic, they'll do. But with anything else having to do with 3D printed plastic, the best solution is some CA glue in the appropriate spots. And you can fix just about anything. Okay, I'm not going to tighten that one all the way down yet. Try to keep this in camera view while I'm installing the servo. All right, now I let the linear gear slide a bit, so I have to back these out and reposition. I wasn't watching exactly what I was doing, so gear forward. Now, put the screws in. Okay, there we go. All right, now, be right back. I'm going to get an airplane with the receiver in it and test this. Okay, I've got a transmitter on, batteries plugged in. I've got one of these hooked onto this airplane already, but it has a Y connector. So, there we go. Now, let's hit the switch. There we go. See the rod fully retracted? So now let's put our Test bomb in place. There it is, holding on. Let me hit the switch. Oh, there it goes. All right. That completes the assembly of this pylon. Now I have one on the bottom of this airplane. I'm going to lift this up so you can see it. There it is. Same type, same servo, except, let's see if I can get this in view. The pylon mounts are 90 degrees to the left and right. I have them off to the left on the forward side and off to the right so they could screw into these popsicle sticks I have glued on there. All right, so previous damage from a bad landing, which is what this airplane is suffering from at the moment again. Landing gear is a little squashed, but the landing, I pancaked it, and that punched a hole through my hatch there. But I just opened it up, cleaned it up, so it's a new air cooling vent. But in any case, you can see the servo movement. All right, so that's mounted on my utility plane. Let's put this up here where we can see it, I hope. And there we go. Pylon complete. Just need to mount it on your airplane now.